Well, this may not be the most exciting piece of positive news you've gotten, but it's actually pretty interesting. Scientists in Singapore have broken a long standing limitation on the ability to generate electricity from flowing water, suggesting that another elemental force of nature could be leveraged for renewable energy. Rain. With the simplest and smallest scale test setup, the team could power around 12 LED light bulbs with simulated rain droplets flowing through a tube, but at scale, their method could generate meaningful amounts that could rival rooftop solar arrays. Singapore experiences significant rainfall throughout the year, averaging 101 inches of precipitation annually. The idea of generating electricity from such falling water is attractive, but the method has long been constrained by a principle called the Debye length. Nevertheless, the concept is possible because of a simple physical principle that charged entities on the surface of materials get nudged when they rub together. As true for water droplets as it is for a balloon rub against the hair on one's head. If you haven't done that as a kid, it creates static electricity and your hair sort of attaches to the balloon. Kids do it all the time. While this is true, the power values thus generated have been negligible, and electricity from flowing water has been limited to the driving of turbines and hydropower plants. Big dams like the Hoover Dam. However, a study published in the journal ACS Central Science, a team of physicists has found a way to break through the constraints of water's Debye length and generate power from simulated rain. Water that falls through a vertical tube generates a substantial amount of electricity by using a specific pattern of water flow. Plug flow, says Sioing So, author of the study. This plug flow pattern could allow rain energy to be harvested for generating clean and renewable energy. The authors write in the study that in existing tests of power production from water flows, pumps are always used to drive liquid through small channels, but the pumps require so much energy to run that the outputs are limited to minuscule amounts. The authors set up to harness the plug flow pattern was scandalously simple. No moving parts or mechanisms of any kind were used. A simple plastic tube, just 2 millimeters in diameter, a large plastic bottle, a small metallic needle. Water coming out of the bottle ran along the needle and bumped into the top section of the tube that had been cut in half, interrupting water flow and allowing pockets of air to slide down the tube along with the water. The air was the key to breaking the limits set by the Debye length and the key to the feasibility of electricity generation from water. Wires placed at the top of the tube and in the cup harvested the electricity. The total generation of rate greater than 10% resulted in 100 watts per square meter of tube. For context, a 100-watt solar panel can power an appliance as large as a blender or a ceiling fan, charge a laptop, provide for several light bulbs, or even a Wi-Fi router. Because the droplet speeds tested were much slower than rain, the researchers suggested the real thing would probably provide even more than their tests were, of course, on a mini scale. Pretty interesting stuff, and I think many of you will find this fascinating. See you on the next one tomorrow.